everyone, we're going to be continuing working with application problems in this worksheet. So go ahead and pause the video and read through that first problem. Okay, and as always, we want to draw a picture to help us understand what is happening. So we have a soccer field, and it tells us that we have light poles that are located 20 feet from the sideline. So let's go ahead and do 20 feet from the sideline. We're going to have this pole. We know that the light is at the top of the pole, which is 52 feet high. And then we know that the beam of that light is going to hit the center of our soccer field, which is 36 feet from the sideline. Okay, and so when we look at this, we end up with a nice triangle that has a vertical height of 52, a horizontal height of a total of 56. Okay, and then the question is, what angle should the lamp be set to meet these conditions? Meaning we want to know what angle should we change this lamp to make sure that it's hitting right at the center of that field. Okay, so which means that we are looking for this angle of our triangle. I'm going to go ahead and call that alpha. Doesn't matter what you call it. If you called it theta, that's fine. And so remember from previous worksheets, we want to look at the sine, which is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And our tangent is opposite over the adjacent. And so when we are looking at this particular triangle, we want to think about which sides do we know. So our alpha angle is what angle we're looking at, which means that 52 is going to be the adjacent side to that angle, and then the 56 is going to be the opposite side to that angle. And so when we look at our functions here, sine, cosine, and tangent, you will see that tangent is the one that uses the opposite and the adjacent. So that means we're going to be using the tangent function for this problem. So we've got tangent of alpha is equal to our opposite, which is 56, over the adjacent, which is 52. And our goal is to find that angle, right? So we want to isolate that angle. To do that, we have to take the inverse to isolate the angle. So then we get tangent inverse of 56 divided by 52 equal to alpha. So now we've isolated our alpha. We can solve that. Let's go ahead and, in this problem, let's go ahead and work in degrees. So go to mode, make sure you're in degrees. And then for the solution, after plugging that in, you should get that alpha is equal to 47.12 degrees. Okay, so the angle of the lamp should be 47.12 degrees. Okay, on part C, we're going to change up our problem just a little bit. So it says, based on the angle found in part B, if we increase that angle by 1 degree, what is the increase in the distance from the base of the pole to where the center light hits the field, right? So if we think about our visual, we've got our light. So if we increase that and we change that if we change that lamp 1 degree, instead of hitting at 36 feet into the field, where's that new light going to hit? Okay, so we have an angle of 47.12, but we're now going to increase it by 1 degree. So that means that our new angle is going to be 48.12 degrees. The height of that pole is not going to change. It's going to stay 52 feet high. And then the question is, where is that new light going to hit? Okay, so we're still working with the same sides of the triangle, so we're still going to continue working with our tangent function. So tangent of theta is opposite over the adjacent. And if we look at the variables that we know our angle measure and we know our adjacent value. Go ahead and put those and label those again. So 52 is the adjacent, x is the opposite. So we're going to plug in what we know. So tangent of 48.12 is equal to the opposite, which is the unknown, over the adjacent, which is 52. We want to solve for x, so what we're going to do is multiply both sides by 52. So we get 52 tangent 48.12 is equal to x. And then we can go ahead and plug that into the calculator. You should get that x is equal to 58 feet. Okay, we do need to be careful though. 58 feet is not our answer, because if we go back to our question, it says, what is the increase in the distance? So on our previous triangle, our distance was a total of 56. Okay, once we adjusted that light, that is now going to be a total of 58 feet. So we are looking for the increase in that distance. So the increase in distance of where the light hits the field will be 2 feet. Okay, so with word problems, always make sure that you are answering the question that is being asked. So often I've had students get to 58 and then they stop. So just make sure you're answering the actual question. All right, let's go to part 2. So go ahead and pause the video while you read this question. Okay, and then one of the things that didn't come through on the visual was the water line. So there's actually water right here. That picture just didn't come out very well. So as you're looking at this picture, you want to think about that you are actually standing in the river and looking up the river. And so if you're standing here, this is your visual, you're in the river. And what we're trying to do is put some pipe underneath the river. And so the pipe is going to be all through here, and then it's going to come back up through here. So the question is, what is the length of the pipe? Okay, so if we look at this, we actually do not have a right triangle, and all the problems that we've worked on so far have been with a right triangle. But the nice thing about this visual is we can create a right triangle. So if I put a line right here, notice we've got 2 separate triangles, and each of them have a right angle. So what I encourage you to do is pause the video and solve this problem on your own. All right, so here is the solution for that problem. So the function that we need to be using is going to be the sine function, because the sine function, based on the angle that we are given, we know the opposite side, we are trying to find the hypotenuse side. So that is why I use the sine, because that is the function that had opposite and hypotenuse. So we plug the values in, we want to multiply both sides by x, and then divide both sides by sine of 4.962 to get x by itself. Remember, when we get this solution of x equals 2275, that is just one side of the pipe, and so we need to double that for the total length of that pipe, for a grand total of 4,550.6 feet. So that is the length of pipe that is needed. All right, let's go ahead and take a look at the third problem. So pause the video to read the question. Okay, so again, with this particular visual that was given to us, we do not have a right triangle. So what we can do is create a right triangle in our picture. So we have 2 triangles now. The one common mistake that is made when looking at this particular problem is students want to assume that the left side is the same as the right side on this triangle, but we do not know that to be true. So we have to figure out what this length is, and then separately figure out what this length is. We cannot assume that this triangle was cut exactly in half, which means that this side was 1.325 and this side was 1.325. That is not true. Okay, what I encourage you to do is first try solving this problem on your own, but in the video I will walk through how to solve it. There are multiple ways to reason through it. But like I said, I highly encourage you to try this on your own, and then when you get stuck, come back to the video. Okay, if you are absolutely stuck at where to get started, I took this vertical line that we created and I called that X, and then found the length of that X. So we knew our angle measure. We didn't know the opposite, but we do know our hypotenuse. So I used the sine function because that gave us the opposite and the hypotenuse. And then we get this length right here of 1.28. Okay, I encourage you to again pause the video and try continuing to work on your own. Okay, another step that you could do is find the length between this lighthouse and where we drew the line. So it's finding, I labeled it A. If you labeled it a different letter, that's fine, but just finding that distance. So based on our triangle, I'm going to use the cosine because this A value is adjacent to that angle and we are still given that hypotenuse. So I used cosine because we had the adjacent and the hypotenuse sides. And when we do that, we get A is equal to 1.13. Okay, again, I encourage you to pause the video and try working the rest on your own. If you get stuck, come back. Okay, the next step would be to find the distance from the center of our triangle over to ship B. So I labeled this length right here, B. We know the total length was 2.65. We also know A was 1.13, so then we can subtract that to give us the B value of 1.52. Okay, pause the video and continue to try working on your own. And the last step is to find the distance from ship A to ship B. Since we have a right triangle and we know 2 of the 3 sides, we can use the Pythagorean theorem. So 1.52 squared plus 1.28 squared equals our c squared. Simplifying that, we get 3.9488 equals c squared, and then we take the square root of both sides, and we get 1.99. There are additional ways to solve this. For example, instead of using the Pythagorean theorem, you could have done the angle right here, we'll call it alpha. You could have done tangent to find the angle and then done sine to find that distance. The work would look like this. Okay, and with this work, you will see that we also get 1.99 miles. And there are different spots that you could have solved it differently as well. So for example, on part 2, instead of doing the cosine, you could have used the Pythagorean theorem here to find that third missing side. So there's lots of ways to solve these problems. The key is to really think about what values you know, which ones are missing, and how can we solve for that missing variable. Okay, the summary for these past 2 worksheets are really just to make sure that you always draw a picture when working with application problems. That helps you organize the information and knowing what you know and what you don't know, and then trying to find trig functions or Pythagorean theorem to help you fill in those missing pieces. So always draw a picture. All right, that is it for this video. We'll see you in the next one.